recording, and there I am. Whoa, didn't mean for that to happen, but it happened anyways. So, um, can everybody see my screen and hear me? You type in the chat. Is what?
Yeah,
Yeah.
we can.
Okay, good. Perfect. Sounds good. So, well, welcome to the LaTeX tutorial. Thank you for coming. We have a wild turnout tonight. And so today we'll just go and I have some things planned for us. Just learn a little bit of LaTeX from scratch. It's really not that hard. So it really doesn't take too long to learn it. It takes a little while to be able to do it like quickly, but to know what's happening in the code, it's not too bad. So hopefully it's not too scary while we're doing this. But basically, I'll start with just what is LaTeX, right? So LaTeX is a typesetting language, or a markup language. So it's a way to just write down equations and mathematical formulas and stuff like that in a way that is just like easy. So easier than the Microsoft Word equation builder, and you have to click stuff and blah blah blah. So the goal is that you should be able to type these. Eventually, you should be able to type mathematical equations as fast as you can just type a sentence once you are used to the typing. So, and it doesn't take that long to get there, to get to that point, to be able to type that fast. So, yeah. So today we're going to be doing just like an introduction to doing all that, and I have just a few things planned for us. So if you want to follow along, feel free to follow along. You can use overleaf.com. So overleaf.com is basically like a compiler for LaTeX. It'll compile a LaTeX code into a PDF document. Overleaf is entirely on the browser, and it's free, and you don't do anything like that. There are compilers you can download as well. So I do use one that you can download. So it's called TextMaker. I don't know where the logo is. It's not, but TextMaker is one that I don't use Overleaf anymore, but Overleaf is great. I to be honest, I should go back to using Overleaf sometimes. I feel like I should, because it's pretty good. So yeah, so basically, Overleaf is what I'd recommend if you'd like to follow along. So I'll talk for just a few minutes if someone would like to get their Overleaf working, just for 2 minutes here. I'll pause, and then I'll show you how to start a new project. But LaTeX isn't just using Overleaf and not just using TextMaker. So you can use LaTeX in a lot of different programs that let you type math. So like Microsoft Word, for example, has a LaTeX mode. So if I go into Microsoft Word here quickly, and I want to write an equation, right? So I could insert equation right here. And yeah, here there's basically, you can like try to do it yourself, like make a fraction and then put the numbers like 3/5, right? And it becomes tedious when you're trying to do something complicated. But it also accepts LaTeX. So if I go again, insert, and then equation, there's a LaTeX button right here. It's automatically selected for me, and I can just start typing in LaTeX, right? I can just start typing. I forget exactly what syntax it wants. 3/5. I just click enter. There you go. Right. And sure, maybe for a fraction, it's easier to just type the fraction. But if you have a big complicated expression, it is easier to do it in LaTeX by far. And you can type again. The goal is you can just type the equations as fast as you can type your regular words in between it. So yeah, so just wanted to show like LaTeX works not just in Overleaf or any particular program. It's just a general kind of markup language for mathematical equations or expressions, whatever. And so Word, and then Notion also allows for LaTeX, right? So here's an example. This is my 501 notes. So like this right here, it's a little equation box, and that's LaTeX code right there. It's not super complicated. You'll understand this by the end of it. Yeah, and so it's right here's like there's that integral. That's the code for that. So yeah, okay. So if I'm gonna start on Overleaf now. If anybody, again, if anyone wants to follow along, feel free. If you have any questions throughout the tutorial, feel free to let me know. We'll see how long we go. I mean, it's for 2 hours, but I mean, we'll see how long. How much stuff I have to talk about. Sorry if you hear stomping. I think the upstairs neighbor is is stomping actually. So that's probably it. Let's start by we'll make a new project. So that's like a new document. I'll just make a blank project. I'll just say LaTeX tutorial. Hopefully I can make the text bigger. I just realized maybe that would be beneficial. Yeah, there you go. Can I somehow not rich text? I don't really care about rich text. No. Is there any way for just instead of just scrolling in, is there a way for me to do it? No. Okay. There's no like settings. Okay, I'll just zoom in like that, and then it'll update you. Actually, that actually works because it reformats it. Okay, so in Overleaf, when you start a new project, it gives you a bunch of stuff already, right? So let's just go through this quickly. Basically, document class article is like the document class you almost always use. There's other document classes in LaTeX, but this is the one you like. I have always used document class article. I've never used a different one. And then we have a bunch of different packages. So LaTeX has a bunch of packages which lets you do different markups, just like any programming language has different packages you can import, modules of code. So there is that for this as well. So I'm going to add a couple packages that almost always get used by these things. So this is just by default. Just leave that one by default. To be honest, I'm not quite sure what it does, but just there. So first thing, LaTeX uses a backslash, not a forward slash. So you use this way, not this way, right? So it's always a backslash. And then we're gonna open another package, so use package, and then there's basically just a couple that you always use. So AMS math, which is American Mathematical Society math, and then use package AMS fonts, just more math. These just give specific things that the code can do. And then use package AMS sim, right? Okay, so this isn't too interesting. It's just packages that I'm putting into the program here. It's just extra little symbols that we can do. And then we'll also put in just one last one, which is graphic X. There you go, graphic X, which is going to let us put pictures in. Put pictures in. So pictures is like a little bit of a annoying thing to do, so I'll show you how to get around that. But anyways, that's that. Now, you just, the first line of code is just what's the title, LaTeX tutorial, author. This is all automatically generated by Overleaf. Date, whatever. Begin document and end document are the little tags that start and end what you're actually going to write. Make title produces this whole thing, which is the arrangement of this stuff. So if I get rid of make title, because we don't particularly need make title, we also don't particularly need section, right? We don't need to define our sections at the moment. Notice that nothing changed, so you have to recompile. That's the thing about LaTeX, you do have to compile. Okay, didn't like it. I think it didn't like graphic. I think it's graphics X. Is that what it didn't like? What's wrong? LaTeX error. It doesn't like graphics X. I don't know why it doesn't like that. Oh, what does it not like? Oh, AMS sim not found. Okay, that's what it doesn't like. Okay, for some reason, that's what it is. Oh, it doesn't like more things. What does it not like? Is it that I put stuff in here? Is it that I didn't put make title? Wow, great start, fantastic start. Make title. Is it that I'm not making the title? Oh, it's that I'm not making the title. Okay, that's an Overleaf thing. That's not that's it. It forces you to make the title for some reason. I don't know why. So that's what it was. So let me actually put back all the packages that I uninstalled, and can I just make title now? Learning a little bit as we go. No, it is still something that it doesn't like here. Okay, whatever. I'll erase these for now, and then we'll cross the bridge when we get there when it needs it, because eventually we will need it. So anyways, we can start actually typing some math now. So let's start actually doing that. Let me just move this to the side a little bit here. Can I make this? Can I zoom? Oh, can't zoom in. Okay. So in LaTeX documents like this, if you want to start with just like an equation, right? You just want to write a line that's an equation. There's a few ways to do it, but probably the most reliable way is you do this. You do these kind of brackets like this. So backslash, square bracket, backslash, square bracket. Everything you write inside here will be interpreted as an equation. Everything you write outside here will be like a sentence, hello. So if I recompile again, it's going to be like just a sentence hello, but everything I write inside here will be interpreted as mathematical equation. So from here, you could just do the obvious stuff like 3 plus 2, right? It'll interpret this as an equation, and to be more precise, it'll interpret it as like a block equation. So it'll take it out of the sentence. What I mean by that is if I do hello, my fave equation is, and then I do this 3 plus 2. That's different than if I did hello, my fave equation is, and then these dollar signs, and I do the same thing 3 plus 2. And I'll show you what the difference is right now. Show you what the difference is. If I recompile, hello, my let's zoom in. I could zoom in here. Yes, I can. There you go. There you go. So hello, my fave equation is 3 plus 2. This is an inline equation, right? Or expression, whatever. This is inline, which means it doesn't break the line. This is a box equation, or a block equation. So it makes a little block here, a separate line, and it writes it like that. So it depends on what you're trying to write, right? Like if you're trying to write a whole big thing, then you probably want to put it as this. But if you want it inline, then you write it with dollar signs instead. You just write, and I can write after this. Wow, that's great. And then it will put it after. So far, the point is we have these square brackets with a slash to be a block expression, and we have the dollar signs to mean a inline expression. So yeah, so we can do the stuff you'd expect. I'll almost always use the block expressions here just because it's a little bit bigger. So we can do lots of things. Like again, like I said, 5 plus 3 equals 8, right? We can do this, and it'll post like that. It'll just format it properly, right? So let's talk about doing more complicated things now then, right? So like, what if you want to do exponents? Let's see here. So what if I want to do like 5 to the power of 3, whatever, it's something I know, 2 to the power of 8 equals, or 2 to the power of 3 equals 8. So you use the little caret up, like the up caret for that expression there. Again, that's pretty much as you'd probably expect, right? That's probably what you'd expect it to be. And so it puts it up there. But what if you wanted to do 2 to the power of 32, right? Well, you'd probably expect that you put a 32 here, but let's see what happens when you do this, right? Not what you wanted, right? So it interpreted this as 2 to the power of 3 followed by a 2, right? Which again is not what we want. Sometimes that might be what you want, but that's not what we mean here. So whenever you want to group multiple things together, you put little curly brackets around. So these curly brackets now are denoting that the 32 should be treated as one object, and that's what this up is referring to, this object here. So now when you run this, it'll be 2 to the 32. It doesn't equal 8 anymore, but equals something. I'll just put question mark. Will it do question mark? There you go. And that's a trend that always carries on in LaTeX, is that you have these curly brackets which denote that you're grouping something to be treated as one object. So we're going to use this again when we have, like, we're doing integrals, and you do upper bounds and lower bounds and stuff like that, right? And you can like combine things and so on. So yeah, so far we can write regular expressions. We can write exponents. We can group things into an exponent, right? Let's see, what other basic symbols can we think of? So exponents. Yeah, what if you want to show multiplication, right? So of course you can do 5 times 3, right, equals 15, but it's probably not going to look right, right? I mean, maybe you do mean a star. Some people mean a star, right? But usually you don't mean a star, because especially if you're in 532, then you mean, that means convolution. So instead, there's lots of other options. So I mean, of course, you can just write it like this if you want to denote multiplication like that, and it will update accordingly. But what I usually do is I like to put a little dot. I like to do 5.3. Actually, I usually write it like this, to be honest. But sometimes I also want to write multiplication as a dot. And so you can write dot. I think you can write dot. No, dot puts that. Oh yeah, that's what dot does. So what I do is C dot. C dot is center dot. So center dot, we'll put it like right in the center there. So that's how I usually write it. So notice that when I use a special character like this, I have to put a backslash first, and that denotes that this is going to be like a special character that LaTeX is interpreting here, right? So if I want to write 5 times 3, I would write 5 C.3. Now, yeah, I mean, this might look a little clunky to write equations in. So of course, writing 5 times 3 is not a very complicated equation. But when you start writing integrals and stuff like this with vectors and blah blah blah, it becomes much faster to do it like this compared to any other way I know. Especially combining equations into your math. I mean, Word is pretty good at it too, but that's because it has LaTeX there. Okay, so we know how to write this. I mean, you can also write, if you want to write like across for times, you just write the word times. So that's going to be that. So how about I just copy this here. This is going to be C dot, so we can see there. And so there's our, different ways of writing multiplication. Or dot, this, or if you want a star, you can do a star. You can do brackets, however you'd like. Okay, so that is, those are some basic symbols. Let's talk a little bit about fractions now, right? So what if I want to write, 5 over 3? How do I write 5 over 3? I mean, you can write 5/3, and this will write it like that. And sometimes you do mean it like that, right? But what if you wanted to actually write it as a fraction, right? As you'd probably seen it in other markup. Well, you use this command. So frac, right? F-R-A-C, and then 2 curly brackets. So it takes 2 arguments, a numerator and a denominator. So on the top, I want a 5. On the bottom, I want a 3. So frac 5/3 will be the fraction 5 over 3, written like that, right? As we'd kind of expect. But there is an issue that kind of happens with that. I mean, that's as simple as fractions are. I mean, you just write frac and then the 2 things, and then you write what you want to be in there. What can be in here can be anything. So if you want to put a whole expression in here, of course, 2x plus 3, it will figure it out. 2x plus 3. There you go. It'll format it. It'll stretch the line and everything like that to be the correct shape and everything. Okay, but there is an issue that comes into play when you have something like, whatever, 2 times, 3x plus 5, right? So if I write this, that's how you'd expect it to look, right? That's exactly how you'd expect it. But what if I want this 3, instead of a 3 here, I want, 6 over 7, just some number. So let's see how that would look. If I write 2 times, okay, so 6 over 7, I'll write as a fraction. So frac 6 over 7. And then x plus 5, right? So frac 6 over 7 is going to be the fraction 6 over 7. And then we have x plus 5. But this is not going to look right. So when we plot it, or not plot it, but when we compile it, that bracket doesn't look right. You usually make the bracket bigger, right, to make it fit the whole thing. There's a way around this. So you, instead of having these, I just put spaces here. The spaces don't do anything, by the way. So if I recompile this, spaces don't do anything. So if I want instead to have big brackets, I would just put slash left before that and slash right before this one. This tells it to be a big bracket, basically. So now the brackets adjust properly, and they have they're the correct size like that. So the slash left, slash right, basically that with the bracket, after it, that tells it to be the big size. Not even like the big size, correct size. So if this wasn't a fraction here, it would just correct. It wouldn't be big anymore. It would just be normal size like that. So just putting that left right, it basically just makes it actually update. Oops, make it like actually update to what it should be. I'll put 6 over 7 back. Yeah. Okay. So far we have done different types of ways to put equations in text, basic expressions, exponents, groupings, little commands like c dot, times, frac, right, kind of stuff, left bracket, right bracket. But how do you do symbols, right? How do you do like interesting symbols? So like, what if I want to write, let's see, something from, I don't know, from the electromagnetism textbook. I don't know, those are weird things, right? This is from the this textbook. What if I want to write like, well, we'll deal with integrals in a second, but what if I want to write, actually there's too many vectors in this. Here, what about this? What if I want to write this? Exactly what we see here. dt equals epsilon naught et equals 0, comma, dn equals epsilon naught en equals rho s. We basically write it exactly like that. We basically just, the whole point of this is that it's basically you just write it like you would write English, but it's like as swiftly as you would write English. is what I should say. How should maybe I'll put it here. That's too many things open. Okay, just so we see it, I'll just move it here. That didn't work. Okay, believe me. Actually, I'll leave this here. I'll leave that right there, and then that will. There you go. I'll leave that like that. Let's say I want to type exactly this. Maybe even the box. To be honest, I can even do the box after too. But for now, let's just type this. So I'm going to start with, it's not an inline math equation. It's a box math equation. And I write it basically as you'd expect. So D, I want a subscript. So I use an underscore. So dt is going to be D subscript T equals. Okay, and now I need to figure out how to get this epsilon character. You can try epsilon. Well, let's see what happens. So I'll say epsilon. I want epsilon not, so I'll say underscore 0. And then I'll put a space e as well. Equals 0. Notice the spaces don't mean anything, right? So I could even not put a space between epsilon not and e, because remember, if I don't put these in brackets, it's not going to be a subscript 0e. It just takes the first character. So let me recompile this, and then you'll see what it looks like. So that's pretty much what we wanted, right? This epsilon is not the exact epsilon that we were looking for, right? It's a different epsilon. So there's lots of different epsilons out there. But it basically is that I use var epsilon. So var epsilon is the epsilon that we want. This the curly one. It doesn't really matter. It's just up to how you want to write it. So if you want to write var epsilon or you want to write epsilon. And yeah, so you don't have to like click the symbol on the side window. You know, sometimes that's a common way to do it, is like you like with other programs, you have like a table where you click the symbols that you want. When you write it like this, sure, it's a little bit of a long name, but you don't have to like stop the flow of writing. You just keep writing, and it's you can just type that out. So var epsilon is the key for this symbol here. And every Greek letter has a special like key like this, special little tag or whatever you want to call it, right? That refers to that symbol, and it'll just put that in its place. So yeah, but let's finish the other part of that equation, which was this, right? So can I make it halfway? No, can I? There we go. I wish there was a way for me to show multiple things on the screen, but this will just disappear if I put it in. So let's just finish the equation here, right? So if I want to put a comma and then a space, a few ways you can do that, right? So you can put a comma. If you like, comma is fine. It'll just put a comma there. But if I write dn after, so dn, let's just say I'm just writing dn. If I write that, I think it's not going to look exactly how we expect it to look. Let's see. Yeah, well, there's not really much of a space there, right? There's like, maybe that's enough, but that's definitely not the amount of space we have here, right? If you want to put more space there, remember, adding spaces doesn't do anything, right? Adding spaces doesn't do anything. Just hitting space. So instead, you gotta do something else. So the space character to add a space is backslash comma. Oops, didn't work. Backslash comma. And you can do it a few times if you want. Backslash comma, backslash comma, backslash comma. And that added some space, right? And it's kind of how we have it in that equation. Stuff like that doesn't really matter, but if you just want to write the equation how you want to write it, you do have control over that. And then now let's just finish writing this. So var epsilon not, right? So var epsilon underscore not underscore 0 en equals rho. Again, you just use the Greek letter. You just say the Greek letter, rho. And the backslash is what triggers it to be like a command that you're calling to put a different symbol there. You don't literally mean rho, like the letters R-H-O. You mean the symbol rho. So the backslash is what triggers. We compile this. It's now... Oh, I didn't put an equal sign. Oops. There we go. So there's that equation from the text. So there's a huge amount of these symbols that you can use, right? It's not just rho and var epsilon and all these things. There's countless ones, right? So if you want to write like the gradient is the little triangle, right? Maybe can I pull it up? here's something. What is this? Oh, this is me trying questions. So let's, where's, let me just open it. So if you want to try, I don't have my tablet here, but if you want to try writing like gradient of f, right? Sorry, I don't have the tablet open. Let's see how that works, right? So that gradient, it has a name, right? It's not just it's not just a triangle or gradient. It's a Greek letter. So you have to know the name of the Greek letter. That's the important thing. You can use that very fast. So that Greek letter is actually called nabla. So if I want nabla f, I write nabla f. And there we go. Now what's important is that I do put a space here. If I didn't put a space, I have an issue. It won't do. It'll either throw an error or it won't draw it at all. Because nablaf is not something that it knows what to do, right? Nabla space f, see f is not blue anymore. So it knows that f is not part of the actual command here. So nabla f will be, again, that's kind of the whole reason that putting a space doesn't actually do anything, is because you need to separate things sometimes with spaces. But that's it, yeah. So nabla f is the name for that. What if you want to do like delta x, right? Delta x. So let's try that, right? Delta x, right? Like change in x. Let's see what happens. Not the right delta, right? So this is also delta, but it's not the delta that we want. So Greek letters also have capital and lowercase version. So we actually, what I mean when I say delta x, like change in x, is a capital delta. So how do I get a capital delta? You just put the first letter as capital. So now capital D delta x is going to be the right thing. It's capital delta x. That is what I care about. So if a Greek letter has a capital and a lowercase version, then you just capitalize the first letter of the command. Similarly, right, if I want to write like, resistance equals 25 ohms, I wonder if ohms actually is a command. That would be kind of surprising. No, it's not, right? So it doesn't understand what ohms are. Even does ohm? I never tried this actually. Let's see. No, it doesn't. So what you have to do is you have to know what that symbol is, right? What Greek letter that symbol is. So that is an omega. That is an omega. But a different omega, right? Not this omega. It's a capital omega. So we want to do a capital O on the omega. And so now that's resistance. So yeah, okay, so that's that. Let's take a moment and maybe do just a little exercise, right? Of like trying to type something. So if I just write an equation here, I'll just handwrite it quickly. I'll just handwrite it quickly, and then we can try it. Plug it in here, maybe. So what if I want to write something like something complicated? I don't know, something that we often see. But again, I'm just avoiding vectors for a second, just before we talk about that. Roles and all that. Just basic equations. So I don't know. What if I want to write like 2x plus 3? Maybe this is over. Well, I can't do over 2 because of this one. Over 7. I don't know. Equals 8x squared over 2x plus 4. If I want to write this expression, right? So basically, this is how the code's gonna work. I'll just type it here, just so that we can see it next to each other. So of course, in this, right, that's the syntax for having an inline equation. Let's just start from the left side. So it's going to be a fraction to begin with, right? The fraction is 2x over 7. To that, I want to add 3 equals another fraction. So remember, fraction is backslash frac, open, close these curly brackets. 8x squared. I could put curly brackets around the squared if I wanted to, just to make sure, but it doesn't matter. And then 2x plus 4. All spaces don't matter here, it's just for legibility. So that's the code to write this here. So if I go back to overleaf and put that in, it will be what we expect. It will type it. So yeah, so we're getting kind of to the point where this would take a while to type into Microsoft equation Baker. I mean, if it depends on how good you are at it, but I think it's easier to just write it like this. It more matches how you'd say it, right? The fraction 2x over 7 plus 3 equals the fraction 8x squared over 2x plus 4. So we're starting to see like why it's faster to do it like this, hopefully. So that's that. That's like working with these things. Let's see what's next on my list of things to discuss. Yeah, I guess we can look at like there is a list of symbols that are available. So I'll say LaTeX symbols list. Let's see this one. Yeah. So there's like you just look it up, and there's a list of all the symbols that it understands, right? So Greek letters, here's all the Greek letters. Here's like, for example, all the different thetas, right? There's a bunch of different thetas you can use. There's a bunch of different, where's the omega? Here, omega and omega, right? Capital omega and lowercase omega, that's what I was showing. And then, yeah, and then we have lots of other things, right? So we have all these symbols, and they all have their specific, like, code for it. So if I want to say less than equal, I would say \leq, less than equal. And at first it might be like, you have to look up all these symbols, but you do remember them very fast. Like they're not crazy complicated, right? So LEQ is less than equal. So greater than equal is GEQ. So the parallel is the two parallel lines, right? And in is how you do the XER. Oh yeah, I want to talk about that. I think that's on my list. Yeah, it's on my list here. Talk about sets. But there's lots and lots of symbols, right? Lots and lots of symbols. So I don't know why that's a repetition, but anyways, here's all the different sets and all that, right? The different like R, all this for all. So you just write the word for all, and it's the upside down A. This is logic notation. So obviously you can look this up yourself if you're typing in LaTeX. You can just do this here and just Control F what you're trying to look for, because otherwise it's all pretty self-explanatory what is here. So if you want to do like the partial derivative, right, you would do partial / partial. Let's do that maybe now, actually. If I want to write the derivative of a function with respect to x, so of course you can do this lots of different ways. You can say, okay, let's say f of x equals 2x squared, right? That's our function. And then you can of course write f prime of x equals 4x, right? Just by putting an apostrophe for the prime. So if I compile this now, you see that it compiles like that. But what if I want to write d by dx? Well, it's a fraction, right? It's a fraction. So frac df dx, right? Or you can write dy dx, it doesn't matter, right? Equals 4x. Or you want to write it differently, you can write it as frac d dx, and then f on the outside equals 4x. Right? So the difference here is that I put an f inside the numerator, or I don't put it inside the numerator, right? This depends on how you want to write it. It doesn't really matter. They're both correct. You want it to be a y instead of a y, instead of an f, then you put that there. But if I want the partial derivative, right? So let's say I have f of x, y, sorry, put it. So if I have f of xy equals 3x squared plus 4y, I don't know, there's my function, right? Or I'll say g instead. G of xy is that. Then, and I want the partial derivative, right? I want the partial derivative. Well, we have, there's lots of notations for it as well. So if I want to write, you could write f underscore x, or f subscript x, which is the partial derivative with respect to x, of xy equals, partial derivative with respect to x would be 6x, right? But you could also write it as a partial derivative, like with the fraction, right? So it is a fraction. And so you use, sadly, you have to actually write partial, right? Which is kind of a long one. That's kind of a long thing for it. So partial, that gives you like the partial d, you'll see in a second. The partial f partial x equals 6x. And that's what we'd expect it to look like, right? We want it to be the partial f partial x. That's a fraction. And yeah, that's pretty much it. And let's say second derivative, if you want to just have, I guess it's not f, sorry, it's g. You want to write the, for example, the second derivative of a function, like say this f here, I want to take the second derivative. Of course, you can write it as f double prime x equals 4. 4, right? Yeah, 4. But what if you want to use the notation? Let's compile this quickly. What if you want to use the notation, where are we? Like the fraction like this, like d by dx, right? So what that looks like is it's a fraction again. So you always start with frac and then 2 brackets. And then it's d squared f by dx squared, right? So it would be d squared f by dx squared. That's the notation for that, right? And yeah, that's and again, it's basically like as you'd expect it to be, I think, right? Like if it's a square, you just put caret up 2, and you put it on the right symbol, and it'll put it on the right symbol. It does all the actual figuring out how to format that for you, right? You just have to actually just tell it what to do. So yeah, so that's working with fractions, derivatives, partial derivatives, arguments into functions. You just put brackets, and it'll format it how you expect it to look like, right? Greek letters. It's a whole list of Greek letters we saw there. There's different variations depending on which one you actually want, right? When you actually care about. And yeah, that's that. So I'm just thinking, is there anything else I want to talk about before I move on? I have other things to talk about, but just before I move on. Okay, I think not. So let's do integrals. So how about I just show you how to like section off things? If I want to have like sections, maybe a table of contents at the end, it can generate it for me, right? So let's say this is section 1. So I write section in brackets, and I put the title of the section. So let's say introduction. And I recompile, it'll say 1 introduction. This is my introduction. Then maybe, here we start doing Greek letters and functions. So let's say I go, that's right here, right? So I'll make a new section. I'll say Greek letters and functions. And then I put that there like that. And then now, I'll put derivatives here. I don't know. But this section is derivatives. And then now we will move on to vectors. Vector notation. So it generates all the section headers for us. It puts little numbers in the front. If you want to generate the table of contents now, super simple. If you have headers, if you do sections like this, super simple. After wherever you want, you just say make or backslash make table. What is it? Table of contents. Is it make table of contents? Table. What is it? Sorry, forget what it is. Make table of contents or table of contents or make table of contents in LaTeX. Table of contents. There you go. That's what it is. Table. Yeah, it's a table of contents. Like compile this. There you go. I don't know why it wasn't showing up as autocomplete. It does it for you, and it'll show the page numbers too. Here, right? It'll show the page numbers here. It generates it all for you. If you have subsections, so let's say introduction here is, let's say the subsection here is subsection, different ways to use equations. I don't know, the different ways to use equations. And then let's say, I don't know, here I'll start doing second derivatives. So subsection, second derivative. I spelled that. I recompile it. Yeah, there you go. It automatically puts in the subsections for you here, and page numbers included as well. Now, if you can format this the way you want to format this, right? There's ways to do that, but maybe look that up after, depending on how you exactly want to format it. The basic format is pretty enough, so you can like use it like that. But yeah, So I just wanted to show quickly how sections work in table of contents and all that. One more thing that I found really useful is like I usually don't like to have numbers. I just think it's kind of annoying to have numbers, like especially if like the course does the chapters out of order. I don't like to have like section 1, chapter 3, or and then it's like section 2, chapter 1. Or I don't know. Like if the course goes through the textbook out of order, I don't like having the numbers like that. So the way you get rid of it is you just put a star right after the word section. And what that does, it kind of does two things. It removes the number. It actually technically also removes it from the table of contents. Kind of annoying. There's some ways around that, but it's kind of like a little bit too technical. So like for right now, you can look it up after, obviously. So for now, let's just leave it. But if you want to get rid of if you want to remove it from the table of contents and you want to remove the number, you put a little star. Okay, let's try some vectors. So for vectors, it's what you'd expect, to be honest. Most of this is what you'd expect. I think that's what I keep saying, but you want something to be written as a vector. So let's say I have the vector, whatever, some velocity vector v, right? So we put a backslash, we say vec, and then we put v in brackets like that. And it will end up being a velocity vector. It has a little arrow on the top, right, for velocity. But that's not the only way to write vectors, right? So you could also have it in bold. That's very common to have like bold letters. So you just say bold. Let's say electric field, bold E. And, oh, it didn't do it. Why didn't it do it? Bold. Is it bold vec? I forget how to do it. I almost never write it like that. So that's why I forget. Bold vectors in LaTeX. See, just Googling it is well, 95% of the time the right way to do it. It'll get you the answer. Let's see. I thought it was just bold. I swear I did this before and it was just bold. You just do Control B on it and then is it now bold? No, it doesn't make sense. Oh no, it did work. Okay, so can you just do vec? I'm discovering things here as we go. Let's just see. Yeah, okay, that's all it is. So if you just even in the math environment, which is between these brackets called the math environment, you can say like E and then highlight it and do Control B. You can also manually type /text BF boldface is what BF is boldface. But that's too long. So you just highlight it and Control B, and it will do it like that. I think there is a /bold too, but I just can't find it now. So even in the text environment, in the math environment, it'll understand what bold should look like. So yeah. Okay, great. So there's that's vectors basically. There's not that much else to say about writing vectors. So if I want like the vector PQ between points P and Q, right? I would say vector PQ, and it knows to stretch the vector out to the correct size, right? Oh, it didn't stretch the vector out to the correct size. Oh, there's a way to do this in a different way. Yeah. There is a different way to do it. Sorry. Vector long vector arrow LaTeX. Yeah. As I said, I remember that it does it the right size. It doesn't actually do it the right size. Yeah. So this isn't the right size. That's the whole point. That's what I meant to say. Definitely. This is not the right size that you want to have it here. So there's ways to fix this. Like you want to have control over it, so they give you lots of options. So one way to do it is to say over. I think you say over arrow. I might be wrong. I'm guessing here. Let's see. If I just do over arrow, PQ. No, it doesn't look like it likes it. No, it doesn't like it. So you have to tell it what direction to. Over right arrow, PQ. And now it does it the whole way there. It does the whole right arrow like that. And then you can also, of course, say over left arrow if you wanted to. None of this stuff you have to memorize, right? You just have to know that you are able to do this and that you can then Google it if you need to know how to do this, right? That's how you do most coding, right? You just need to know what you are able to do, how to find that information, and understand putting that information together. So here, right, of course you don't have to memorize this, but that's kind of how you'd want to do it like that. I'll leave it like that. So yeah, so that's writing vectors. I would probably, to be honest, like I would just write it like that, even though it's too short. everybody understands what you're trying to say there. And yeah, that's that, I guess, for vectors. I can't think of anything else that might be relevant. Yeah, can't think of anything else. Subscripts work the same. Oh yeah, I guess I'll mention subscripts. So if you want to have like v1, v2, so I'll say you just compare these two. So by oops, that's not what I meant to do. Sorry, there you go. v1 and then v1. Compare these two, right? The only difference is the _1 is inside the bracket and the _1 is not inside the bracket. I would always put it outside the bracket because here it centers the arrow over kind of both of them, and here it centers the arrow over just the v. Very, very minor detail, but I think this is the correct one to use, right? This is the one we mean. The arrow should be over the v, not the v1. Minor difference, but again, you do have control over that, right? So you can control how you want to express it. Okay, so we've done vectors. Let's open up another section. I'll talk about integrals now, and how to type integrals. So integrals can get kind of messy, right? Actually, I think it might be a good example. I guess integrals and sums. Integrals and sums. Probably a good example actually is to do 532 notes, right? To just type 532 notes, because it gets pretty, like, there's a lot of integrals in there. But just like today I was doing the Fourier transform notes. So maybe let's try to write this. Let's try to write this equation here. Should I write that one? Oh, we'll do complex numbers too, but anyways, let's write this one, I guess. So all right, let's do something simple first, and then we can do that after. Yeah, and then we'll do the Fourier transform. So I'll show you how to do like this stuff as well, like typing something like that, right? Which gets pretty messy. So let's start with just a basic integral, right? Just like the integral from 1 to 2 of x dx. Let's say I want to do that. The integral from 1 to 2 of x dx. It's as you'd expect. Backslash, because we want to do a special symbol. Int for integral. Int. Okay, from what to what? Subscript. Where are we going from? Subscript 1. You don't have to put these curly brackets. It'll understand if you just put the first symbol. I like to put curly brackets anyway. So integral from 1 to 2, right? But right after each other, one after another. You put the bottom one and then the top one. You can put the top one and then the bottom one if you want to. You could put in this order if you wanted to as well. Oops, that's not it. You could do it in this order as well. It'd be the same thing, but it makes more sense to put it like this because that's how we usually think about it. The integral from 1 to 2. Oh, sorry, I have to put this in a math environment. Forgot to put it. I type in Notion, so I don't have to put these things. So I forget. But anyways, the integral from 1 to 2 of x dx. This is going to look approximately like we want it to look. It's not going to actually look exactly like we want it to look, but pretty much, right? The integral from 1 to 2 of x dx. Now, usually you leave a little space between the function and the dx, right? You leave a little gap there. So I always put a backslash comma just to denote that there's a little space there. Now that looks more like what we mean for it to look, right? X dx. And it doesn't really get that much more complicated, to be honest, right? If you want to put something else in the upper bound, like 3a plus 7, that's lower bound, it'll just put it there. And it knows how to format it to be the right size, right? Just put it in the brackets. What about to infinity, right? What if you want the integral to infinity? How do you write the infinity symbol? This is used all the time, right? So slash infinity might work, I don't know. That's not the one that yeah, maybe it does work. Slash infinity? No, it doesn't like it. Infinity is not a command. For whatever reason, it's infty. I-N-F-T-Y. Not for whatever reason, just so it's shorter. I-N-F-T-Y is the infinity symbol. And yeah, and it knows how to do this. So if I want to do the integral from negative infinity to infinity, I just say negative and then infinity to infinity. And yeah, and so notice if I didn't put these brackets, I mean, the whole thing would be screwed up. Maybe not the whole thing, but like a lot of it would be screwed up if I didn't put these brackets, right? I have to at least put a space there. Right, that's what I get. It is literally doing what I say. So it's the integral, subscript the negative sign, then infinity to the power of infinity, x dx. But of course, that's not what I mean. I mean with the brackets here. The brackets do make a big difference. What about a double integral, right? What about a double integral? Well, you just do I int, like two i's. Double integral. Let's say over some region R of f of x, y, and then I'll put a comma slash dx. So there's double. Oh, I didn't like it. Why didn't I like it? What did I not like? Undefined control set dx dy. No, can't be that. Didn't like the int. Why didn't I like the? Am I remembering it wrong? Can't be. Double integral in LaTeX. Oh, it's I think I have to have one of these packages that I got rid of at the start. Let's see which package is the one that I'm missing. Oops. Yeah, there it is. Int. Why is that not working? It's even in the LaTeX thing. I think it should be automatically with LaTeX. That's weird. I'm just looking at the overleaf is what I meant to say there. This is the overleaf page. Integrals. Integral. That's this integral. Well, the word gather doesn't matter there. But yeah, so the multiple integrals are these extra i's. I just don't understand why it's not letting me do it. I think there's a package that I'm supposed to install, and they're not telling me which package. Oh, here. There you go. AMS math. That's the one that we're supposed to have. Use package, AMS math. So let's put that there. Hopefully it compiles. Yeah, it compiles and it puts the double integral. There you go. So quick problem solving of how to deal with that. That's what it is. Why is it so blurry? Recompile. There you go. So you need AMS math to have the double integrals. But there you go. So now if I want to do a triple integral, it's exactly as you'd expect. It's 3 i's for the over some volume v, something dv there. And there you go. Right? It knows where to put everything there like that. And see how. So there you go. So that's doing the multiple integrals. And if you want to do like a circulation integral, right? If you want to do like a surface integral with the circle, like you put a circle through it, that's OInt. OInt. Maybe OInt, and then whatever. Some vector space, or some vector field, right? So let's say I have some vector f, and then you do dot ds, let's say, right? This is kind of a vector field line integral. So or a surface integral, actually. This is a surface integral. So yeah, so you put the f vector, which is why I put vector f, right? C dot, because I want to dot it. I do want to actually write a dot here. And then ds vector, but the s is the vector, right? Not the ds, but the s is the vector. So you put d and then vector s. That's how I write it like that. And so you get some sort of expression like that if you want to write it like that. So yeah, there's doing integrals. I don't know if there's anything else to mention about integrals. I mean, if you want to do a double integral with different bounds, let's just say quickly, right? So if you want to do like the integral from, I might just write it quickly here. If you want to do like, where am I? The integral from I don't know, 1 to 3 of the integral from 0 to x squared of whatever y squared x dy dx. Let's say I want to do this, right? I'll show you. This is how you do it. So you do it as two separate integrals, two separate integral symbols. Right. So where? That's what I'm trying to. So you'd say the integral from whatever I said. What did I say? 0 to 1 to 3, 0 to x squared. From 1 to 3, followed by the integral from 0 to x squared. And now we have the actual thing to put in, right? The actual function, which is y squared x dy dx. Y squared x dy dx. So we just write it as you'd expect: y squared x, and put a little dash comma, backslash comma, dy dx. Spaces don't matter. So if I ever put a space, it doesn't make it. And there's your integral. What you do. You just treat it as two separate. So yeah, so that's how we write integrals. And then sums, I guess sums and limits are also probably important. So for so this is for integrals. I'll just put a subsection. Integrals. And then subsection sums. So if you want to do like a discrete sum, it gets, as you'd expect, slash sum. Now, let's say I want to do from n, so from n equals 1 to infinity. Let's say that. The sum n equals 1 to infinity. So underscore n equals 1 is subscript n equals 1 to infinity. It knows where to put it. It knows that you don't mean like exponent infinity. You mean like on top. It knows that when you do a sum. So let's just put our sequence, whatever. I'll say fraction 1 over 2 to the n. And now we do that. And see, it knows to put the infinity symbol on top, and it knows to put the n equals 1 on the bottom. Not like as an exponent and a subscript. It's like the correct spot. And yeah, there's that. That's working with sums. Doesn't get that much more complicated after that, right? Is there anything else for sums? There's not really actually anything else for sums, I guess. Just like discrete sums like that. That's fine. Actually, if you wanted to write out, like maybe if you want to write out a couple terms, right? You could say that this is equal to 1 over 2 to the 1, right? Plus 1 over 2 to the 2 to the 2. So notice I'm just using frac terms, right? Frac 1 over 2 to the 1, 1 over 2 to the 2, plus frac 1 over 2 cubed, plus dot dot dot, plus frac 1 over, well actually there's no end. So plus dot dot dot. So how you write that. And that's pretty much what you mean. Only thing is the dots, that's not in the right spot. You want that to be in the middle, right? You don't want that to be in the bottom there. So you can kind of control the orientation of these dots. Very minor detail, but you can control it. So I always do C dots. C dots again means center dots. And then, so if it was C dot, like singular, it would just be 1 dot. But if you make it plural, C dots, it does like 3 dots. And that's what you mean. You want to put it in the middle there. You could also do V dots, right? Vertical dots. I think you could also do D dots, diagonal dots. I think you can do that. Yeah, there you go, D dots, right? But C dots is what we need in this case. So yeah, so you can probably imagine like typing this out. You can eventually type it out as fast as you can just type regular sentence. Once you know all the stuff, once you know how to type this. Doesn't take all that long to remember, and Google is very helpful with answers. Lots of forums for this kind of stuff. So people very often need help with this. So yeah. Yeah, that's since I just saw Mana said that's how I do most coding. Yeah, yes, that is the Googling things. Yes, absolutely. Okay, so let's continue that. I don't know what else did I say. So I skipped sets. I don't know why I skipped sets. Vector calc. Oh, let's do cross products, I guess. Let's do like just look at that quickly. I guess I can go into under vectors, to be honest. If I want to do dot products and cross products, oh, dot product, it's just C dot, right? That's not too crazy. I'll put this here. So if I want to do dot product, so anything I don't put inside of a math environment will just be text, right? So dot product is just vector v C dot vector u, and then compiling this. There you go. You want a cross product, it's going to be, well, going to be vector v times vector u, right? Times. So the times is like the actual cross there. And then if you want to also do like divergence, right, which is like vector calc thing, right, then you would do nabla C dot vector f. nabla c dot vector f would be what you want, right? Because you want the divergence of the vector field f. And if you want the curl, right? Then, oops, then you would do nabla times vector f. And that would be your curl. Because again, nabla is the symbol for, that's what the triangle is called. Nabla. Times does like an actual cross, and then vector f puts the little vector on top. You could do bold f if you wanted to as well. It doesn't make any difference, right? So if you prefer to write it as a bold f, you would just put an f and then Control B makes it bold, and okay, same thing. So yeah, so that's divergence and curl. We did integrals, we did sums. Let's talk about sets quickly, right? So I'll just make a new section here. Sets. Let's say I want to write down this set. I'm just making up sets, but let's say I want to write down like this set. I don't know. Oh yeah, we'll do. Oh, I didn't even talk about column vectors. Let's talk about column vectors. Okay, so we'll do that at the same time. So the set of whatever vector is x, y, z in R cubed, such that x plus 3y is greater than or equal to 5. Let's say that. I don't know. That's our set here. That's our subset, not a subspace, but our subset. So let's try it out. How would we write this? I wish there was some way for me to put the two pictures on the screen at the same time, but there is. I mean, I can just split screen it, but it doesn't look that good when I do that. But I'll try it. There you go. Try it like this. So let's start from the left side. So I want to put this. First of all, I want to do the set brackets, right? Let's see what happens if I just do that. Well, the set brackets are the brackets we already used, right? We already used set brackets for something else. When I use set brackets, it'll either throw an error or we'll just put nothing. Just put nothing. 3 is just from the page number 3. So I have to, whenever there's a symbol that's already used in LaTeX and you want to use that symbol, just put a backslash before it. And now it knows, okay, interpret this as the actual curly bracket symbol. So now it puts that. And if you want to make it like big to correct to size, you also can put like left and right here. It understands. We don't want that here. Actually, we will want that, but for now. Okay, next thing is this column vector. How do we write this column vector? There's a few ways to do it. There's a few ways to do it. So let's look at how to write this column vector. Let me do it in the vector section just so that it's not so messy. So let me go back to the rest of the vector section. Derivatives, vector section. So column vectors. Let's say I want to write this vector x, y, z. So this is how we do it. You want sometimes inside of the math environment, you want to make a new kind of math environment. I can't remember. Which is like a vector environment. So you do /begin because you're beginning a vector. And so we can say /begin B matrix, means bracket matrix. That's what we're doing, the B matrix. And then we ended with /end B matrix. So you have to have both of those. And now we got to put something in between these lines, right? So we want to have x, y, z. We'll talk about matrices in a second, like doing full matrices. But for now, we just say begin B matrix, end B matrix, and then we put what we want there. So x, new row, so next row, I put double backslash, means next row, y, double backslash, z. If I did this right, it should work. So let's see. Yeah, there you go. It is what we expect. So column vector, x, y, z. Column vector, x, y, z. And so that's how you'd write it. You'd, in the math environment, /begin, x, y, z, and matrix. Now these don't have to be on different lines. You can do these on the same line. I just wanted to avoid that, but you can do these on the same line. The double backslash means, okay, next line. Right? Next line. We'll talk about how to have multiple columns in a second, but just for this second, this is all we need. So I'll type that again here. This is going to be begin B matrix, begin B matrix X, next line Y, next line Z, and then I want to end B matrix. So far we've written this. In is just /in, just as simple. And then this R, this fancy R, you could just write capital R, but I think \R works. So if I try that, I've never done this one before. I always have a different way, but I just saw did it do it? No, it didn't like it. It doesn't like yeah, I put the /R to try to do the fancy R, but it just didn't write anything because it just doesn't know what /R is. I thought I saw it here, to be honest. I thought I saw, if I say LaTeX list of symbols, I think I have to have a package. I mean, I know another way to do it, the way I always do it. I just saw here, yeah, here I just saw that notation, LaTeX. It seems to have it, /R, but it's just not working. I don't know why. I have no idea. It doesn't really say. The way I do it is I do /mathbb, and then in brackets R, /mathbb in brackets R. And if you want like the integers in the fancy letters, then you do mathbbz. BB is Blackboard bold, and that's the font that these things are written in, so Blackboard bold. It might not like it, it might say I need a package. Yeah, so I do need a package, right? Undefined control sequence means there's some package. So what package am I missing? Let's see. Mathbb in LaTeX. It'll just say there's some use package AMS fonts. That's what I need. AMS fonts. So let's use AMS fonts. There's our AMS fonts. So there you go. Now we have the R is the correct kind of R that we want. I want these brackets to be bigger, right? I don't want them to be so small. So I'm going to put left, and I'm going to put right here. And that should work, hopefully. Nope, didn't work. I didn't like it. Left, right, didn't like that. Big, curly brackets. LaTeX. See, Google will help us here. Yeah. Okay. I'm just missing a backslash. Okay. So again, you have to have a backslash on there. So /left backslash bracket. Now it'll be the right side. Okay, so we're almost there. Now I need to write, the line. So the line there's just a character on your keyboard that is the line. So you can just do that. And then x plus 3y. And now I want to say greater than or equal to. So it's GEQ. This is also something you just find from that big list of things. So GEQ is greater than or equal to 5. So there's our thing. Why didn't it close? I don't know why. Oh yeah, the word right. I put this the word right. That is correct. And there's our set. And if I want to say like S equals this, I just put S equals in the front. And now S equals that. It'll format it, it'll center it, it'll do everything. Put it in the right spot. Okay, so there we go. That is working with sets as well as vectors, actually. So we covered vectors as well, right? So you do this like B matrix stuff. Let's maybe do matrices and then piecewise functions, and that's pretty much all I have to cover. There's not that much else to even talk about. Anything else that you want to do that's more specific is you can figure that out once you get to that point of being able to format things. Google's very helpful in finding those things out. But yeah, so let's just finish up here with matrices. I'll just put that after the vectors, right? It makes no sense to put it after the vectors. So I'll say section matrices. So we saw a bit of how to do a matrix, like a column vector, but what if I don't want to do a column vector? What if I want to do a whole matrix? So let's start with just regular matrices, and then we'll do augmented matrices. So you have like a line through it. We'll do that too. So /begin B matrix. begin B matrix. And then you want to end B matrix as well. Right? Begin B matrix, end B matrix is just the beginning and end of the B matrix. Spacing doesn't matter. Be aligned. There you go. And now you want to write this matrix. So let's say I want it to be like, say I want it to be this matrix here. Let's say I want it to be 2, 3, 6, 0, 1. So that's the matrix I'm trying to make. So, we write it like this, basically. So let's try it. So again, you are in a math environment with these little brackets here. It means you're in the math mode. This means matrix mode. Okay, now everything inside here will be interpreted as a matrix. So let's start. 2 is our first element. You use the ampersand to go to the next column. So 2 and 3 and 6. New line. So double slash means new line. 0 and 1 and 5. New line. You don't actually have to end the last line, but I'll end the last line. And that should work. Let's hope it works. So if I go here and I go there you go. Is the matrix that we care. So I think from this you can imagine how you'd make any size matrix. Doesn't really matter. You can also put like expressions in here. So if you want to have like the integral from 2 to 4, from 3 to 4 of x dx as one of the elements of your matrix, that's fine. It'll put it in there, and it understands what to do. Yeah, so that's kind of working with matrices. If you wanted to do the same thing, but you want a determinant instead, if you want to have the same matrix, I'll switch this back to a 5 or whatever I said, 3. So if you want it to be a determinant, I think you just say A matrix. Oh no, I don't think A matrix is right. I think it's V matrix. I think it's V matrix. Yeah, V matrix. So that's just like vertical bars instead of things. So that's like for a determinant. And now augmented matrix. Let's say I want to augment this matrix. Let's say I want to put the augmentation line where you'd expect it to be, right there, right? Let's say I want to augment it with that. Well, you just basically, if I recall correctly, in brackets here, put where you want the line to be. So if I put 2, let's just see what happens. Didn't work. Square brackets, maybe? These supposed to be square brackets? Sometimes arguments are with curly brackets, sometimes arguments are with square brackets. A little bit unrelated. No, that didn't work. That doesn't. I have it here. I have it written down. I have it in this document. And then this is Gaussian elimination. So A matrix. Yeah, and it should be. Oh, sorry, it's an A matrix. Sorry, I didn't switch it. That's what happened. A matrix for augmented matrix. So for A matrix, so instead of begin B matrix or V matrix, it's supposed to be A matrix. And now what I said was right. You put just where you want in curly brackets where you want the line to be. Still didn't like it, so let's see why. A matrix undefined. Okay, so A matrix undefined. That means there's a package that I need for A matrix. So LaTeX package for A matrix. Or I'll just say augmented matrix. So I don't need to do that. Build your own environment. I would extend an AMS math. Yeah. So AMS math is what I need. I think that's what it's telling me. AMS math. I have AMS math. Okay, so what's with that? What do I have here? Oh, yes. I remember this actually. So this one, make letter renew. I don't know. Let's just copy and paste this in. See what happens. Where is it? Oh, here. Here. So sometimes these things, yeah, actually, I think it's like literally this that I looked at months ago. So sometimes you need to create what's called a new environment inside the code. Don't worry too much about what it is. Like someone will come up with this for you on some Stack Exchange website, but you can make new environments, which is like a custom version of something. So in this case, we can use this, right? A matrix, and I can just put it in here. So new environment, a matrix, right? And this should now work because I made a new environment. There you go, right? Notice that our brackets are curly now, which is not what I wanted. I didn't want curly brackets. So again, I can just look a little bit at the environment was happening. So instead of doing, I don't know what all this means. To be honest, I have no idea what all this means. But I do see begin array, end array. I don't want an array. I want a B matrix. So I think if I just say B matrix, or no, so that's, yeah, B matrix, or B matrix, that should work. Yeah, and then, whoa, that did not work. Let's see. Let's see. Come on. Let's see what my code is. I have it working here. I don't know what's going on. Right. Oh, yeah. No. Array was fine. Array was fine. This was the issue. Instead of curly bracket, round bracket, I'm just going to switch these to square bracket. Now when I recompile, it will be what we want. So the conclusion to make an augmented matrix is sometimes you have to Google things. This is a little environment, new environment that you can put into your code, right? I switch these to square brackets from the Stack Overflow. And now what this lets me do is it lets me do an A matrix and then just put where I want the bar to be. So after the second one is what that means, after the second. Okay, there's not that much else to do except piecewise function. So let's just say, do I have a section called functions? Greek letters and functions, yeah. So let's say Greek letters and functions. Greek letters and derivatives, right? So let's say I have a subsection here. Piecewise functions. So piecewise functions are a little messy. They're also like this environment thing, the slash begin slash end, So slash begin. It's called cases. That's what it's called. It's not called piecewise. Slash begin slash end cases. So it doesn't like it. Why doesn't it? What? What does it not like? I don't understand what it doesn't. Unexpected slash end cases after open display math. Is it not like that it's on different lines? Not sure. But this will not compile, will it? Oh, no, it did. Does it not like is there end document not there? No, it's there. That's weird. That is how you do it. That one I know. That one I know. I'll look at my notes from Notion here. So in Notion we do in 532 we have piecewise. So here I have begin cases, end cases. Okay, so it is fine. It is begin cases, end cases. What is that like? Let's just type an X in here or something. So it says, oh, I'm saying being. That's the thing. Begin cases. There we go. I do that more often than you'd think. I do say being here quite often. So begin cases, end cases is correct. It's just typed it wrong. So let's say I want to define like the unit step function, like u of t, right? U of t. I want to define u of t. So u of t equals begin cases. We just define the cases. So the first case is that it's 0, right? It's 0. And you put the ampersand, which means, and now you put the case, right? What's the possibility? It's kind of like a matrix, to be honest. You're just having a matrix there. So then the second column is the case. So this is if t is less than 0. New line, double slash, new line, 1. And the case is t is greater than equal to. And this will be your piecewise defined. It'll sort it all out. So you can put whatever you want around it, right? So if you want to then, I don't know, u of t equals this plus 5. You put plus 5 after end cases, then it'll put a plus 5 after, as you're telling it to do. Probably wouldn't want to do that, but if you did, you could. So just to recap how we did piecewise functions, you are in a math environment, you do begin cases, end cases, and in between, this is all being interpreted as a piecewise function. So the first element of each list is the value, and then the condition. Value and condition. And again, if you want to have something crazy here, instead of a 1, you want to have the whatever, o int over I don't know, some fancy, I don't know, whatever, some surface S vector f c dot d vector s, like you want to have some kind of surface integral there, it's fine. You can put it there and it'll sort it out. It'll format it all correctly. So yeah. Okay. That I think is all. That I think is all for that I had to cover today. Oh yeah, the only thing that's annoying is images. So which kind of leads me to just the conclusion here is that I don't use Overleaf. Overleaf is good because it's just like anybody can use it for free and you don't need to install anything and it's automatically working. Oh yeah, and by the way, you can just like click download PDF here and it'll download the PDF. But the issue is like pictures are pretty annoying. So you can't drag and drop pictures into here. You need to use this package called use package graphics X, graphics or graphics X, whatever. I think it's graphics X, graphic X. And you have to do complicated things, to be honest. Like you have to upload it to Overleaf. First of all, you have to upload the picture here to Overleaf, and then you have to put a little command here to put the picture in. I'm not going to show that because I think most people, if you're one to type notes, you'll use either Microsoft Word or Notion. Notion's also good. So Notion, you can just drag and drop pictures in. Pretty much that is the reason I use Notion, is that you can drag and drop pictures in. Also, I like these little callouts. You can do these things called callouts. I like these little callouts here, so that looks pretty. Otherwise, Notion has a lot of issues I don't like, but it does let me drag and drop pictures in. And that's pretty valuable. It saves so much time compared to other things. So yeah, so that's basically the reason. Otherwise, I would be using Overleaf. It's just pictures are annoying. Even in this text maker thing, pictures are dealt with the same way as Overleaf. So I would recommend using Notion pretty much just for the pictures. The fact that you can just drag and drop pictures in. If you can find a nice way to do that in other programs, like Word is also drag and drop, so that's good. There might be some other LaTeX writers or compilers or whatever that I am not familiar with that make it easy. As far as I know, Notion is the easiest one. I'm still on the hunt though, so I'll find some good ones. But yeah, that's it then. That's everything I have to talk about. That's my whole list. Took an hour and 23 minutes. So yes, U of T. I just saw that now. U of T. Yeah. Dimitri says that all the time. He says U of T, and I always go, I don't know what I say. To be honest, I don't even know what my feeling is from hearing U of T, but I'm like, different school. That's my feeling. But anyways, okay. How long did it take me to get used to LaTeX? That's a great question. It took me, like, the question was, in case I said that too fast for the recording, how long did it take me for me to get ready? How long did it take for me to get used to LaTeX? I started using it in second semester, and it was like, to be able to do, in that semester we didn't do any of these crazy integrals, right? It was just maybe some differential equations, stuff like that, and some writing. So yeah, like maybe at first it was a little slow because every time I had a new symbol I had to Google it, right? But after probably just like maybe 2 weeks, not even, that's even too long. Maybe, like, it depends on how much you write, of course, but consistently writing in this for, let's say, consistently writing in this for 2 weeks, I could write as fast as I can type English in LaTeX, right? Uh, and then I could also write at a reasonable pace very quickly after that. It really doesn't take too long once you remember some of these symbols. Like you remember how to make a fraction, is /frac. If you have to look that up every time, then it's going to be pretty slow. But it doesn't take too long to remember that. And then little things when you have errors, very Googleable. Google is very, very helpful with errors. So it'll take 2 seconds to Google things to sort it out, as I did many times in this life. So yeah. Okay. Yeah. So otherwise, unless there's any more questions, I will finish off for the night. Thank you for joining. Yeah, for sure. If we find good topics that want to do, I mean, for LaTeX specifically, I mean, that's basically all I know. That's basically everything I know about LaTeX. I'm sure there's a couple more things I didn't show, but that is 90% of everything I know for LaTeX. So that's nothing else really to show. But just events in general, yes, definitely. We have some planned next week. We have an alumni night. I don't know if we actually announced that yet. So I don't know if it's fine. We have an alumni night happening next week, and some other exciting things in November. So we have a lot of events for November. So there'll be a lot of cool things going on. That'll be in person. There'll be in-person events. This was just okay. So that is our time then for today. I'll stop recording.